Good morning, everyone, and welcome to an application approach to solving common challenges in the water industry, brought to you by OSIsoft, now part of Aviva, and GTS Group. My name is Jessica Dickers, and I'm the editor of Utility Magazine. I'll be your host for today's webinar, and I'm really excited to spend the next hour with you exploring this important topic. I'd like to begin by acknowledging the traditional custodians of the land on which we're all meeting today. For me here in Melbourne, that is the Wurundjeri people. And I'd also like to acknowledge the traditional custodians of the lands where all of our Australian delegates are located today, and pay my respects to elders past, present, and future. Now, over time, water utilities face many similar issues. These can include infiltration and inflow from major storms, water quality, plant performance, and challenges with not meeting regulatory targets, just to name a few. These issues impact the resilience and performance of operations, but using data-driven decision strategies can help deal with these environmental and customer service-related challenges more effectively. Our fantastic lineup of speakers today will explore these issues in depth and will help you bring intelligent, data-driven decision-making to the water industry. Now, we have over 160 delegates registered for today's event, and I know you will all get a huge amount from today's presentations. You'll also be able to ask our speakers questions, which I'll put to them at the end of today's session. To submit a question, simply type it into the Q&A box located at the bottom of your Zoom screen. Please also remember to include your name, role, and company in the Q&A box, so I can include that when I ask your question. But I'd now like to introduce our first speaker, Gary Wong. Gary is the Global Industry Principal, Water and Infrastructure at Aviva. Gary is a leader in real-time industrial performance intelligence, and he leads OSIsoft's global data centres, facilities, smart cities, and water businesses. He has 25 years of extensive international experience providing sustainable, strategic, and cost-effective digital solutions. Prior to joining Aviva, he has held positions with Metro Vancouver and as a consultant directing both public and private sectors on operations, digital transformation, planning, sustainability, and engineering. So please join me in welcoming Gary Wong.
Great. Thank you, Jessica. And welcome everyone, and thank you for attending. We have a great session lined up for you today. And as Jessica mentioned, yes, OSIsoft is now part of Aviva. And today, with our partner GTS, we're really excited to showcase water solutions. This is really important for our industry, and these solutions are based on the PI system. And what's really important is that these solutions have been developed over the past several years with our customers in Australia. So the real goal is to not have to reinvent the wheel, and at the same time achieve tremendous speed to value. Next slide, please. So Aviva, we're a global world leader in industrial software and digital transformation. The partnership, merging with OSIsoft is really bringing together the engineering and the operational worlds all together to provide innovative industrial software. And together, OSIsoft has been around for over 40 years, and Aviva has been around for over 50 years. And combined, we have over 2 million licenses installed worldwide. We are traded on the London Stock Exchange and part of the FTSE 100. Next slide, please. So I talked about, the operations and the engineering really coming together. However, we hear a lot about different technologies. Whether that be artificial intelligence, using the cloud, big data that we've heard for a number of years now. Now there's also data at the edge, augmented reality, digital twin, of course. This is something that Aviva has been leveraging for many years, whether it's from the engineering design all the way throughout to operations and maintenance of having that digital twin to really drive performance intelligence. And today we're gonna, with our partner GTS, gonna talk about some of the applications that we have. And if we go to the next slide, please. Those applications are specifically geared for the water wastewater industry. These examples here are the number of examples that our customers have been using the PI system for many, many years. And we really wanted to make it a lot easier for you in the industry to be able to extract that value. So applications basically out of the box. So whether that be using more of your metering data to looking at energy management, pump performance and optimization, water quality, for example, detecting algae blooms and so forth. And we find this is really important, really critical, again, because we don't want to reinvent the wheel. Next slide, please. However, there have been challenges, as you may know, when it comes to data and having data-driven decisions for that situational awareness and having informed decisions based on data. A lot of times we've heard some of these issues, and we actually surveyed over 200 water utilities, and we asked them, what are some of the data challenges that you and your business face? And number one, by far, at 61%, was the ease of access to data, followed by the amount of data, data silos, and then manual data. So with our solutions that we're showcasing today, not only out of the box do you have the ability to basically erase all those data silos, but you'll have easily accessible data with a lot of context in applications and solutions that are driven for specific use cases, as you saw in the previous slide. At the same time, we've looked and we understand as part of the survey that 79% of these utilities thought that the industrial Internet of Things was really important to them. And also we're going to address security as well. Next slide, please. So I'm just going to run through quickly two examples from our customers. One here is Hampton Roads Sanitation District, and they're a large wastewater utility. And as you can see from their dashboard, that it's really that one pane of glass where they use the PI system with a number of applications in their emergency operations center. In this case, they're showing, for example, right now it's hurricane season on the eastern seaboard of the United States. And they have the ability, as you see here, to basically track the hurricanes and the storms that come in and be able to proactively send crews to where those crews need to go in advance instead of being reactive. They have forced pressure mains, for example, and they're constantly monitoring the wet well levels, the pressures, the flows, and bringing in a lot of data, including radar, as you see there, Doppler, and weather forecasts. So it's really, being much more resilient in that single pane of glass that you see here. Next slide, please. My last example here is Great Lakes Water Authority, and they're using the PI system to optimize their pump schedules and to optimize their pumps and the efficiency and the conditions of those pumps. Some of the key takeaways, as you see from this dashboard that they have, is when they embarked upon this journey, it was very quick to get to the results. They basically were able to increase their pump efficiencies from less than 70% to over 82%. They reduced the amount of pump throttling, for example, which was greater than 50% down to about only 10%. And at the end of the day, they were reducing their energy consumption by about 6%. So again, these are very measurable results, achieved by our customer. And I just really wanted to, put you in the right frame of mind to, see what GTS is going to present in terms of the applications, and really afterwards open this up for discussion and have your feedback and Q&A. So with that, I'll hand it back to Jessica. Thank you.
Thanks so much for your presentation, Gary. Gary will be joining us for the Q&A session at the end of today's event. So if you do have a question for him, please put your question in the Q&A box now, and I'll put these questions to him a bit later. But I'd now like to introduce our second session with Steve Hoffman, Director of Sales and Business Development APAC at GTS Group. Steve has more than 30 years experience in the process control and real-time data management market, and he leads GTS Sales and Business Development team. In this role, he works closely with regional managers to expand GTS's presence and supports them to provide exceptional problem-solving real-time data solutions to the water sector throughout Australasia. Joining Steve from GTS Group are Andrew Todd, Chief Executive Officer, and Archie Gale, Head of Innovation. Andrew is a founding partner and CEO of GTS and a familiar face as the presenter at OSI Soft and GTS seminars over the years. With a background in software development, PI system configuration, project management and business development, Andrew is driven to ensure GTS provides customers exceptional services and builds trust by consistently delivering high-quality technical solutions. We also have Archie Gale, who is the leading expert and recognised leader at OSI Soft Technologies within Australia. He has provided training to many of the PI system users in different levels in the utility space to best extract value from their data. He offers expertise in integration of advanced technologies in real-time data solutions to provide specialised analytics capability, machine learning, and specialist reporting and integration services, along with IIoT. But I'd now like to welcome Steve Hoffman to get this session started.
Terrific. Thank you very much, Jessica. On behalf of the GTS Group, I would like to thank you for sharing your time with us today and attending this webinar. Next slide, please. We'll just go to the agenda. From the agenda, I won't spend too much time as we have a lot to go through today, but I would like to say we're trying to provide you with enough content to really show the benefits of the work that both GTS and OSI Soft have done in getting what we see as a paradigm shift from a conceptual idea a couple of years ago to now being able to deliver solutions as a service to our customers, to you. Next slide, please. GTS was founded in 2011 with the focus of providing engineering and support services for the management and integration of real-time data bidirectionally from the source to the consumer. Primarily, our focus is connecting people and information and providing well-engineered, sustainable, maintainable solutions to our customers using best-of-breed technologies. Next slide, please. As you can see here, with a focus on solutions to our customers, which some of them you see on the slide, customers are now looking at GTS to enable them to do more and to do better tomorrow with their data. From this, and years of experience of project engagements with our customers and the experiences that we've gained from this, we have had with our customers an aspect of seeing very similar challenges, I should say, that have been solved primarily by bespoke solutions. So with this and with these similar challenges, you will be seeing today that we've really looked at the concept of delivering a SaaS approach in solving these common challenges in providing well-engineered, deliverable, maintainable, and primarily templatized applications, which Andrew and Archie will be presenting to you today. Next slide, please. In support of this, we've built the largest and most accredited PI Systems engineering presence across Australia to support our customers as they start their digital transformation journey. We see that this, and today I should say, may be the start of this journey, or it could be a continuation of this digital transformation journey in the ability for you as customers to see these solutions as a service, as an application and a subscription commercial model that we hope that you'll see the benefits of that engineering time and development and the collaboration between GTS and OSI Soft with the technology that we'll be presenting today. Now, with that said, we would just like to highlight the fact as well that one of the things that we're very proud of is that we did receive the Best Workplace Award in August for an IT company. So we are extending our capabilities not only to our customers, but ensuring that our engineering staff are well looked after in delivering these solutions. With that said, I'd like to go back to Jessica now to introduce Andrew and Archie for the next segment of our presentation. Thank you.
We'll just bring Archie and Andrew on screen and they're welcome to start the next part of the presentation.
Thank you, Jessica and Steve. So I'll provide a bit of background to the applications that we're going to see. We began working on this concept in about 2017 when the Intelligent Water Networks group in Victoria, the IWN, called for ideas showcasing how data analytics and tools could add value to the water industry. And we became quite engaged with the concept of water communities collaborating through an organisation like IWN. It made a lot of sense to us to share ideas and pool resources towards common goals. But we also knew that the tools available to different water corporations varied quite a bit, and that could be a barrier to being able to implement some of the clever ideas that were provided by others in the community. So we teamed up with OSIsoft to present a concept that took that community model to another level. Our vision, in simple terms, was not just to exchange ideas as a community, but to jointly operate and share a hosted solution infrastructure to provide a technology stack in the cloud with a set of off-the-shelf applications to solve common challenges, accessible to anyone through subscription, and constantly evolving to create new applications under the direction of the water community. And some of the reasons that we love this idea is that it's a technology leveler. Everyone that subscribes gets access to the same technology. And that means that for a lot of water corporations, dozens of spreadsheets are going to be decommissioned. And with that, thousands of hours lost in manual data handling are going to be returned to more productive tasks. And isn't there a great efficiency in building something once and sharing it rather than every water corporation developing their own solution to common problems independently? Also, every corporation is looking for better. Even if you've got some great tools today, and many of you have, tomorrow you'll be looking for something more. And this model provides for an evolving cloud-based technology stack that lets you evolve with it and do more tomorrow. Also, how about access to a sandpit environment to explore new tools and innovative solutions together? One of the things I love about talking to subject matter experts is that they all say, gosh, if I had the time and the tools, I've got a dozen things on my wish list. Well, here's the tools, let's work on it together. So if you're an engineer, this is the technology candy store. If you're a manager or maybe an accountant, it's a cost-effective way to use technology to improve your services. And it's not a futuristic long-term goal. It's in place right now and ready to use. So today, we're opening the doors to the water community to start working towards a better future. Today, we might read about a clever solution implemented by somebody in the community. Tomorrow, we'd rather hear that that clever idea has already been published as a new app. You can add it to your subscription. So coming back to where I started, that vision that we provided resonated with the IWN, and we began working with some very clever people in Victoria, and the Water Apps concept came to life. So let's move on and take a look at some of those applications that the water community asked us to create. Archie, if you can get ready, I will introduce the first one. We're going to start with a look at pump operation and efficiency. This is a great example of how data can be brought together from many different sources, not just as a convenient way for the broader audience to have access to that information, one of those things on Gary's slide, but also when we combine all that information together, we can perform analysis on it and create some substantial insights. So we'll see how asset and maintenance data, operational data, even financial data, operational constraints can be brought together and provide some insights on how a pump is performing, whether maintenance might be required, whether maintenance has been effective, and whether these assets are being operated according to guidelines. Now, previously, this was all done in spreadsheets, very time consuming and really only able to provide a retrospective view of what's going on as opposed to providing some insights in relatively real time so that decisions can be made in the moment. Archie, take it away.
Thank you, Andrew. So to kick things off, what I'd like to do is go into a use case regarding measuring pump efficiencies and seeing how well they are performing. So the first point of call I want to have with this is actually going to be an email alert, because that way, only when there is something that warrants investigation, when we actually need attention, will we actually look into this data set. And by having this in an email format, it means it comes to us when required. We can act on it remotely if necessary, or forward this on to more relevant parties if we find that's actually required. And because of that, we make sure that the email is condensed to only the core information that's required. Namely here, this is on pump station A, and on pump 2, this is the asset in question that has some issue that warrants further investigation. We also make sure that the data being captured includes what's the actual trigger for this. Namely, here we have an efficiency alert. So there's a system calculated pump efficiency curve behind the scenes to tell us how well the pump is performing and do we require any further investigation here. At this point, we did drop below our 75% threshold of 74.992, which is enough for us to then trigger this alert to say if this requires further investigation, we should be looking into this. What's important to note is we also have some additional context for this notification. In this lower table, we can see that we can return this efficiency, but also some more useful information in the greater context. Namely, how long has this pump been running since last maintenance? In this instance, 146 hours. How much is this actually costing us to run it in this poorly performing state? Namely, $753 just this month. And more from the sensor side, what's the actual flow rate going through this pump? This 1400 liters per minute metric, letting us know this is under active load and there are quite a large volume of water moving through this asset. So this is not a trivial alarm we need to really ignore. We must be acting on this with some expedited manner. And from this initial email, I get a glance at what's actually occurring. But to get some more detail, I can instead go to this dashboard here, which gives me a profile of how well did this pump actually perform over this event window. So from my initial drop of 75%, did I recover? And the answer here is quite conclusively, no, I did not. There is a full 20-hour window here where the pump had a degradation in performance. And towards the end, there is a slight chirp in efficiency behaviors, but we never got above that 75% threshold mark. And in fact, towards the end of this, we can see we actually went from a running status to a stop status. So this pump did not recover after 20 hours. Instead, we shut this down. The next question I have for this, wearing my engineer hat, is this typical? Whenever we do have these sort of alarms coming across for efficiency, do we recover? Or is it more like this profile here where we actually run these until a shutdown event kicks in? And to see that, what I'll just do is quickly compare these. And I'll look for all events over all time to see, is this typical or not? And by comparing this to some idealized behavior, I can see that the answer is, well, no, unfortunately, we do not recover. In fact, looking at this 20-hour event that we have over here, it is anomalously long. It is quite unusual. But looking at every other event that we have been recording here, which drops below that 75% threshold, a vast majority of these simply run the pump to failure. We keep running until we have the shutdown state. There are a very small number at the beginning where we actually do have a slight recovery in performance. But it seems to me that if we don't recover within that first 15 minutes to half an hour, we actually do run this to failure. So with this perspective, with this understanding of how we are actually maintaining these assets, I would like to look at this in a greater context. How well do these pumps perform continuously rather than inside these event windows? And for that, I can go to this much larger dashboard. And here, I've broken it up into a few different sections, namely the first one with just some more than nameplate asset data. So what is the manufacturer, the classification of the pump, with rated power consumption, and how long has this been running since installation, those lifetime run hours. And from that, I also have my install date and the last maintenance event here. So I maintained this towards the end of August in 2020. Following that, I've also got some operational characteristics. So less to do with what the pump was or the nameplate data, more about are we running this in a compliant manner. So how long has it been running for this month? How many times do we start it yesterday, or how many starts this month in total? How long are we running this for? What are the actual operational characteristics for this, including how much is it costing us to run this month? And here I can see we're actually sitting at around $1,100 just to run the pump for this month alone. Following that, there's the more traditional SCADA data, those sensor values. Namely, what's the pump running at? What's the temperature, the status code, pressures, flow rates, all the information we'd expect to be measuring, which will give us greater context to these more derived metrics. And from here, I can see that things are certainly looking expensive. We're having a ramp up here in our monthly energy cost. We're also having these drop-offs here in our discharge flow rates, our suction pressures, and our system calculated efficiencies as well. So in fact, what I would like to do is look at these metrics in greater detail. So what I'll do is I'm going to grab this monthly energy cost and also this efficiency trend, and just overlay these in a quick ad hoc trace. And here I can see if I zoom into this final region, there is a dramatic difference here between before the event at around $400 And this sustained poor running event over here, we go up to around the $1,100 mark, and then the $1,200 mark following these events. And I can see that post my 20-hour degradation performance, we had a few more events here. We kept running this further and further into the ground. So at this point, what we actually have is a demonstration of how well the pump, or how poorly the pump is performing as you start running into these more and more expensive and worse performing states. A further question I might have for this is, well, how well does this pump perform compared to other pumps within my facility? And for that, I've got this larger collective view of all 3 pumps at Station A and all 3 pumps at Station B. And within Station A, I can see that while the alarm was initially triggered on Pump 2 with this degradation of performance, I can see that Pump 1 is actually suffering worse than Pump 2, and it follows that very same trend profile. So it is also equally suffering with this degradation of performance. Pump 3, however, appears to be offline and not running at this moment in time. But if I have a look at its efficiency trace down here, I can see that we're always sitting around this 60% mark. We don't have any real highs in our performance characteristics. So while Pump 2 and 1 are degrading, they actually are performing better than Pump 3 whenever it's online. And that's to say nothing about Station B. Within Station B, I can see that Pumps 4 and Pump 6 perform quite deplorably, actually. We don't really get above this 10 to 20% efficiency mark on Pumps 4 and 6. And Pump 5 runs infrequently and typically only sits around the 75% mark. So it's always oscillating around that alarm threshold. So while Pump 2 was the initial alarm generation, I can see Pump 3 has some performance issues which warrant further investigation. But Station B in its entirety, I'd actually say, is a more critical issue. We must be looking to Station B to see why is this performing so poorly, especially Pumps 4 and 6, and what sort of actions we can take to bring those back up to our allowable metrics in terms of efficiencies. And I'll hand it back to you, Andrew.
Archie, I know we're limited for time today, but just before we push on, one of the questions I often get here is whether we can look at a maintenance event in time, and with this cynical view of 60% of the maintenance is caused by 60% of the maintenance, can we see that a positive change prior to maintenance, following maintenance? Are you able to talk to that just very briefly?
Sure. So if I just jump forward in time to the 29th of September, what we have in here is on Pump 2, we've gone down and we can see that drop in efficiency here, going to the 30% or worse. But following the 27th of September, this maintenance event that occurred, we're actually back up to those 90% values, which is what we're expecting from our idealized trend profile. So in this instance here, I can see that when we did conduct maintenance on Pump 2, it was successful and we have returned back up to our ideal performance characteristics. Thank you.
Thanks, Archie. So I just want to say here that we're not going terribly deep into the full features. We're limited in time, so we're just sort of spinning through this fairly quickly. Hopefully you can see from that demonstration that bringing these data sets together does give us some quite useful insights, and through analysis of those separate data sources can help us to make some choices that reduce operational costs. Our next example is RDII, rainfall-derived infiltration and inflow, basically rainfall finding its way into the water treatment system with the risk of adding stress to that system, potentially causing a spill and adding operational costs such as chemical and energy costs to treat water unnecessarily. So this app is based on WASA's recommended approach to RDII analysis. I believe that was originally provided in a spreadsheet form, and we're presenting this back as a more automated and dashboard process. And here we're actually taking a large volume of historical data and using the power of our back-end analysis engine to examine the typical effect of rainfall on water treatment plants, and to show us with some degree of accuracy the actual impact on each catchment area. So this can help us to direct remedial funding where it's most needed to, based on evidence, which catchment is costing the most, for example, which one might be at the greatest risk of a spill in a heavy or prolonged rain event. So again, this replaces a complex spreadsheet that actually took a substantial human effort to compile for analysis. So quite a different story that Archie will show us now.
Thank you, Andrew. So to kick things off, we've got the same notification process here with an email alert. The reason for it is, just like with pumps, we don't always know whether this requires immediate action or this can be deferred to a later period of time or to a different audience. So we try to make sure that this email contains the right information to let the subject matter expert decide what the next actions should be. So here we try to condense the useful information that comes across whenever we have a high flow event. Now, a high flow event, in this case here at the North Catchment site, there are a few ways that can be detected. The first of which is the more traditional flow rate metric, where it's a high volume of water into the treatment facility, and that warrants action to be taken. And that may be more immediate to make sure we can actually accommodate these volumes of water coming into the facility, or they might be able to be deferred if we've got enough of a well ready for us here. So at this point here, we're actually getting 18.986 liters per second. That's an exceedance of our high target value of 15 liters per second. So to me, that would indicate we actually do have some criticality assigned to this. But what's important to note is our RDII percentage value associated with this as well. So how much of this inbound water is actually due to rainfall? And it turns out that from our RDII percentage, we're sitting around 2.9%. Now that's below our 8% target value or our expected limit, but it's still worth noting that there is some non-zero component to this flow. So while we've not triggered on that RDII alarm, at this point, we have triggered on the flow alarm. It's important to also get some context around this, namely the fact that of this 18.986 liters per second measured as my inflow rate, we also have this RDII flow of around 8.9 liters per second. So while that's only 3% of that RDII percentage, it's still sizable enough that without that flow, we would actually be underneath our 50 liter per second metric, our limit here. So while it's not necessarily a rainfall percentage alarm that's coming into effect here, there is still a rainfall component of this flow we need to be aware of. It's also useful to notice the current measured rainfall. So the fact is within this event window here, it's not actively raining right now. So this is likely from a historical or previous rain event, as it does take time for a rainfall to land within the catchment and then make its way through various tributaries to the treatment facility. So if I have a look at this event detail over time, just to see what sort of profile we have for these inflow rates, I can see here, if I just remove some of these limit metrics, that my inflow rate, yes, it was the original alarm coming through at that 18 or 19 liters per second mark. It did cap out at 20 liters per second, which was the facility maximum capacity. But at the 15 to 20 minute mark, we actually dropped back down again to only around 4 to 5 liters per second, but the alarm was sustained. And the reason the alarm remained open is because our RDI percentage picked up at that point. While the raw water flow did abate somewhat, we were still measuring a very high volume of rainfall into the system. In fact, looks like it got to around the 14 to 15% mark, around the 20-minute mark of this event. So while it did not initially trigger as a rainfall event, it was sustained and did push forward with some strong rainfall components. And with that knowledge in mind, knowing how this one event has been handled, I'd like to look at this in a greater context and see how well does this actually perform over time. So within this dashboard, I've broken up into 3 sections again, just like with pumps. So with my quote unquote asset this time, I have the catchment telling me what is the area we have in mind here, how large is this catchment, and what's our predicted dry weather flow. So if it wasn't raining whatsoever, what calculations do we have in the system to tell us what sort of flow rates we're expecting in the facility right now? So we expect it to be fairly stagnant, fairly quiet, because it's not really a high flow window. In fact, looking at this dry weather flow graph, which we have underneath, we can see we're expecting 0 to 3 liters per second as an inflow rate to the system at a fairly predictable weather rate, depending if it's a weekday or a weekend. From here, we also have the treatment plant itself and its peak flow rates, any flow characteristics we have, in addition to the cost. So how much is all of this RDII flow costing us in terms of treating this water coming to the system? And from all those values coming across, we also have those calculated RDII values. And within RDII, we can see how much rainfall do we have versus RDII, what's our flow rate coming to the system, what are some of these more measured values and calculated values that we have in our system over here. And here I can easily see at this time of the dashboard, we have a treatment alarm in place, but not necessarily an RDII alarm. It's well within that 8% threshold. I would like to note as well that while my dry weather flow is at 0 to 3 liters per second mark, my historical inflow rate frequently hits this 20 liter per second mark. And this is just the most recent time in about 3 or 4 these past 3 months. And there have been several other events well in excess of my 50 liter per second target value. So what I would like to do with this is note the correlation between a rainfall event, an inflow event, and the subsequent RDII percentage or RDII volume. So here, what I'll actually do is make a quick trend, just overlaying my rainfall, inflow, and RDI percentage. just to validate my concerns here that while they look to be correlating with each other, I like to overlap this data set and prove this to myself. So here I can see that we are getting a lot of these overlapping spikes over this 3-month window. And if I zoom into one of these spiked regions, I can see that we do have this characteristic behavior of a rainfall event kicks in. We have an increase in my flow rate, and there's a demonstrable increase in my RDI percentage at some point later on. So there is definitely a strong correlation, even if there is some time delay between the two systems, between a rainfall event coming into the system, a measured increase in that flow rate, and that calculation of what that RDI percentage actually is. It's also worth noting that's with a relatively low rainfall event, because it's corresponding to a relatively low dry weather flow at that point. We do have higher rainfall events come across, which may not necessarily lead to higher RDI, but there is always this relationship within some form of rain. We are getting these RDI percentages in exceedance of our limits here. So while I've looked at this one facility with its current alarm and its historical profiles, we have a north catchment. We also have an east, south, and west catchment areas. And within this profile here, what I can actually do is start contrasting these and see, well, how well is the water treatment handling costing us between these different areas? So within North Catchment, we saw the previous screen that it's around 38,000 square meters and $167,000. But contrasting this to East, South, and West, that's quite an anomalous relationship. That cost is disproportionately high to the catchment area. And in fact, if I look at the East Catchment, which is slightly more expensive at $171,000 this financial year, it's servicing a catchment area in excess of 1 million square meters. It's a dramatically larger region. And in fact, looking at South and West, we can see that those are larger areas still compared to North, but cheaper in terms of treatment cost. And in fact, by looking at just this RDI percentage trend, it definitely illustrates that process, how there's an excessive volume of rainfall entering the North Catchment compared to East, South, and West. In fact, within Southwest and East as well, actually, we are very rarely getting in excess of 2%, let alone an 8% threshold, whereas North is sustaining a very, very high value. So the first action sort to be taken with this is to see, well, what sort of lessons can we be taking from East, South, and West, and can we apply those to North Catchment to try and minimize our volume of rainfall that's actually entering the treatment facility. With that, I'll hand it back to you, Andrew.
Thanks, Archie. So one point to make there, in case you're looking at that those treatment costs and thinking that we're out of our minds, I just want to point out that we're using demonstration data here just to illustrate a point. But certainly one of the challenges that was raised by the Water Corps that we worked with was that there is limited budget for dealing with this RDII problem, and it's difficult to apply that where it's needed without this analysis. It's necessary, but it's difficult to do. And if you can imagine the effort that it takes to pull together a year's worth of historical data on rainfall and flow rates from water treatment plants, and then work out the average flows for dry weather and wet weather to try and figure this out, it takes a long time. We can do it every 15 minutes. You can see it happening when the rain starts. So now we're going to look at something a little bit different. It was actually quite surprising to me that the number one pain point tabled by the water corporations that we were working with was the manual effort around collecting and organising data for regulatory reporting. Now, I don't know how many of you might be rolling your eyes about that, but evidently this is a big problem. Actually, on a side note, part of our vision here was that if everybody is providing information into a shared data source, regulators can have access to it whenever they like and do it for themselves. But that's a story for another day. Maybe that is a future objective. So in order to do this, a lot of data from various sources is needed. In this case, we're going to show something from the Essential Services Commission in Victoria. But this information also happens to be pretty good metrics on service quality. So it's actually useful, rather than a painful thing that you have to do every so often. It's actually a useful thing to have in a dashboard so that you can see how your organisation is running. So we've taken that concept and developed it into a dashboard, as well as simplifying the manual process of reporting. It gives us a way to see in relatively real time how an organisation is tracking on some KPIs. Thanks, Archie.
Thanks, Andrew. So as Andrew mentioned here, we're not necessarily looking at sensor data for the sort of dashboard. There's no SCADA system we're listening in to bring out these metrics. This is more business data and business databases we're extracting this information from. And here, at a glance, we can very quickly see that while bursts and leaks look to be compliant, our response time has broken some limits, as have interruptions. So we've exceeded those KPI values just from these simple dials telling us if it's in a green or a red status. We can then look into these further to see exactly how this is all broken down. And from these, within bursts and leaks and response time, we've got our 3 priorities, our interruptions in our planned and unplanned categories. And it's our P3 responses that have exceeded our limits here. And that's very obvious from these bright red bar graphs. In fact, we're sitting at 69 out of 60 year to date and 68 out of 60 for our month to date in terms of our P3 response time. Whereas with interruptions, we're well beyond those limits. We're sitting at 74 out of 30 year to date and 91 out of 60 with our month to date values here. So we've definitely exceeded our allowable limits here for our response times and our interruptions. What's important to note though, is we're getting more than just the instantaneous values and this quick breakdown. Now, while we do have all this at a glance, we can actually go and break down these metrics further and get some greater context into this. Namely, we've actually got these bars in amber, which tell us anything that's not necessarily broken our limit yet. We are still within our KPIs, but it's worth a bit more attention to see if this is something that's of concern and we do need to take any preemptive action to make sure we don't start breaching these limits. Namely, our planned interruptions that are year to date is sitting at 28 out of 30. So we're very much at the cusp of those allowable limits. Likewise, our P1 responses, we're sitting at 28 minutes out of 30 here, which is again right at that limit. And within bursts and leaks, we're averaging 4.2 a month out of our limit of 5. So it looks like with our bursts and leaks, we're actually right at the edge of what's actually allowable within our system on a rolling average basis. And with this, we can actually go a layer beyond this as well. We can actually start going into even more detail by considering the context as to why these graphs shape the way they are. And from that, we have this historical trends underneath. And that tells us when these incidents were happening, within which month of this long period we have in front of us here, 120 days, to tell us, are we expecting this in the future? Can we predict this? For example, within the bursts and leaks, this 4.2 average is strongly influenced from a pretty bad month about 2 or 3 months ago. And that did exceed our monthly KPIs. It did exceed our limits. But long term, we don't really get beyond 3 events in a month, no matter what the priority is. So it's definitely well within our limits here in terms of how we want this to be operating. So yes, while the average is high, going forward into next month and the months beyond, I'm not overly concerned as long as we don't have another one of these large spike events occurring. Contrasting that with our interruptions, these large values here for our current month, it really is just this current month. If I look back historically, we don't really have this sort of characteristics. We don't have this behavior. So in terms of next steps for this, I'll be looking at some short-term solutions here. What immediate actions can we take to try and resolve this and try to bring these numbers down for the current month? But I wouldn't have to worry so much about a long-term solution, as long as this root cause, this explanation for this can be explained by being an anomalous event that's unlikely to occur again into the future. Contrasting this with our response time, our P3 values over here, these have only marginally exceeded our caps, only 10–20% compared with the interruptions almost tripling. But here I can see, looking at my historical trends, we are sustaining these values. We don't actually get below any allowable values for our P3 KPIs. So it looks to be more of a long-term sustained problem. So this requires a long-term and sustained solution to this. There is no quick short-term fix we have for this to try and bring things back into allowable permissible area here, like we may have with interruptions, but it's actually a shift in strategy that may be required here to make sure our response times for P3 are definitely well within our control. And we may look into that within our P1s as well before we start exceeding any of these limits. So there's actually some conclusions we can draw from this data set, not just any immediate actions in our KPIs, but also some historical context and actually understanding and rationalizing the data we have in front of us. With that, I'll hand it back to you, Andrew.
Thanks, Archie. So once again, there was a remarkable amount of manual effort required to pull this together, and this is a very different scenario that we're presenting. And just it's quite a common theme that manual effort provided to generate data-driven insights, and it's one of the key things, the key changes in our technology platform. The next app is all about water quality, specifically health-based targets in our example, and these are based on recommendations provided by WASA, focusing on microbial water quality tests that indicate not necessarily a pass or fail, but whether there might be opportunities to improve water treatment practices. So once again, this was being done in a manual way. It was actually an intern would go through a stack of lab reports and copy the results into a spreadsheet, and then those results would be calculated to provide the answer. And the reason for that is that we're not looking at the raw results from a single sample. We're actually looking over the course of a year to calculate compliance using analysis such as median values or 95th percentile calculations. So it's the history of the results and not just the individual. So some effort involved there. What we showed was that the lab results can be emailed directly into the system. The data can be extracted, stored and analysed, and users can receive a message if there's any result that needs attention. So one of the effects of that is it actually means that the results are being looked at in relatively real time, as opposed to when somebody gets around to processing a stack of files. So quite a difference in process. Let's have a look at that one, Archie.
Thanks, Andrew. So within this dashboard that we've built here, what we have actually collected is every region and every metric that's been captured that we're now recording. So here I've got, I think, 4 or 5 different locations, 6 locations, and 4 or 5 different metrics all being captured here. And at a glance, we can very easily see which ones are compliant and which are non-compliant based on the status indicator. So I can easily see in here that our P3 is, our pH at location 3 is non-compliant. And our suspended solids at location 3 is also non-compliant. And that's without having to do any sort of detailed analysis, because as Andrew mentioned, the system is doing that calculation for us behind the scenes to tell us, are these compliant values or not? And by looking at each of these panels in more detail, we can actually break down in terms of, well, even though it's non-compliant now, historically, how has it been performing? And the answer here is, well, never. pH is 0% compliant this year, just like suspended solids. So it's a persistent long-term issue. And in fact, I can look into this table for even more detail and see the exact readings that I come across, and then the fact that what's the raw result being captured, what's the measured pH, when was it measured, what was the sample date, the sample number, and the lab job number as well. All that useful low-level information is exposed here if you want to start drilling down into that individual asset component, all within this single pane of glass. Andrew?
One more thing, Archie, that something that was raised, a question that was raised throughout this process was that that's a limited amount of information, but it is quite a lot there, and potentially it's going to be many sampling points and potentially dozens of different analytes. And can we drill down or filter this result set into something that's just showing us what we need to give attention to, or look at a specific location or analyte, for example? Can you give us 2 seconds on that?
Yep, sure. So here, what I've just done is filters to show everything that is not 100% compliant. So if we have perfectly allowable readings with 100% compliant over all time this year, those are discarded. And from that, I still have location 3 with its pH and its suspended solid readings, given those are very clearly not 100% compliant. But I also have 4 more sites returned, namely locations 4, 6, 7, and 10 for their E. coli and their suspended solid readings. And within each of these tables here, I can see that we're all sitting at this either 99 and 97, or in some cases 90% compliant. So yes, that is within our allowable limits. That is definitely a compliant metric, but it's not perfect. And as a lower priority activity, what I'd like to do is look into those 4 sites, into those 2 metrics especially, and see what's actually occurring there. What is the cause of these non-compliant events? Was there a historical reason for this? Or is there something more ongoing which can cause these occasional blips in the measured values, which can result in some non-compliant values coming to the system here? So I do get this greater detail in terms of the actual metrics being returned here, and this understanding of what's allowable, what's okay, what might require further attention into the distant future. And with that, what I'd like to do is now bring Steve back into the fold. I'll let him take care of the next section of the presentation. Thank you, Steve.
Terrific. Thank you, Archie, and thank you, Andrew, for a very good presentation and demonstration, showing really the capabilities of these applications which have been developed now over the last couple of years. So one of the things that obviously we need to look at, and I know we're running out a bit of time here, so I'll go through this quickly, is to look at the options. And I think one of the questions that was raised is whether or not you need OSI technology within your premise. And the answer is no, you do not. We can actually host these applications within our Azure environment where these applications are hosted. We provide a data collection node and do an extraction from your systems into our environment. We also look at, obviously from discussions with our customers, that they may already have a PI system, but they don't want these applications to be resident within that PI system environment. Again, the same concept applies, where we can do an extraction from their existing PI system into our hosted environment. And there are some customers which are already invested substantial amounts within their PI system, and would just like to obviously facilitate the purpose-built applications, which are just templatized, and have them running with their own PI system environment. So we do have these 3 options available for our customers, knowing that not everyone from an OSIsoft perspective, unfortunately, has the PI system at each site or within each company. From that, we have looked at a subscription licensing component, which means that you can start off small, purchasing one subscription license, which allows you to facilitate and monitor 50 pumps from a performance perspective, an optimization perspective. RDII is based on obviously monitoring 20 catchment areas or geographical areas. Regulatory reporting is based on a one site perspective. And then water quality allows us to monitor 25 sites. So when you buy another application, you can start off, for example, with pump performance. You can then, for example, look at regulatory reporting for that site. And these applications, as I said, can evolve over time. And the thing that I must remind is what you see and what's being presented is what you get. From the visualization to the analytics which have been applied, all we're looking to do is to connect to your data sets, and they may be all contained within one area of your system at the moment or disparate areas. But as part of the delivery of this, there's an engineering component, which we do, and we work with the customer to find where those data sets are, extract that information, and then associate that information to the applications that you've seen here today. Next slide, please. So in summary, primarily the goal of this is obviously to provide a solution as a service environment, a SaaS environment, different concept rather than software. It's now a solution to really look at the common challenges that a lot of water utilities have and be able to solve them once and then replicate them across many. We are trying to do this and facilitate a more efficient delivery approach in engineering services, but more importantly, an application approach and a templatization of those applications to ensure that we can maintain, deliver, and support those applications for you once you subscribe to these services. We are seeing this as a newer way of delivering solutions rather than bespoke single instance solutions, but delivered by engineering companies like GTS. And we also see this as very scalable. And again, reiterating, you can start small and evolve over time. So we find that very important, especially for what I would consider the tier 2 and possibly local government organizations which have a small water requirement to manage. We can facilitate and do this outside of their domain and provide you with that service of all this technology back to you. We see that by having a shared subscription component, it allows a lower cost model to be made and delivered to all, and also making sure that it really minimizes you as the customer having to maintain this. And we're also seeing that as a bit of a trend, that a lot of people are assigned to do different things. They can't now longer be the master of one. So we're actually allowing ourselves to be that master on behalf of yourselves. So currently we have 5 water apps developed, as you see, from performance optimization, RDI, regulatory reporting. We do have more to come. And we are very excited to work with a lot of our existing water customers, but hopefully new water customers to actually tuning and presenting. So in saying that, I will now conclude and go back to Jessica for the Q&A session. Thank you very much, everyone.
Thanks so much, Steve, Archie and Andrew, for that fantastic presentation and demonstration. So we're now going to bring Gary back on screen as we go into our Q&A section for today's event. So if you have any questions for any of today's speakers, please pop them in the Q&A box at the bottom of your Zoom screen and I'll ask these questions now. So we have had a few delegate questions come through and we'll get stuck in. Our first question comes from Delegate Simon Bunn, who is from Oregon, and he asked, in generating an alert, how much effort is required to stop false alerts at startup and shutdown? Do you have a time window during which the alert condition must be continuously present? So I'll open this question up to all of our speakers.
It sounds like a technical question that Archie might be best placed to answer.
Yeah, Archie, do you have any comments for Simon's question there?
Yep. So within the system here, we can tune this, and we have done this for some of the other alerts regarding RDII to make sure that we're not capturing that sort of flutter that we get during a startup sequence. And in some cases, also putting in an override. So we do actually have that digital signal coming across that this is a startup versus a steady state operational behavior. We can then suppress any alerts that may be erroneously generated in that window. So we've got both profile handling as well as actual state overrides to manage that sort of alarm.
Fantastic. Thanks for answering that question. We'll go to another delegate question. We have one from Robert Reef, who is from Alive Information. And Robert asks, how are you addressing cyber risks?
So in terms of security, there's a few different prongs to this, which we have in mind. So in terms of user access to the system, it's all being managed through single sign-on events as well. So we actually are restricting the data to only the users who have permission to view that data set themselves. In terms of actual management of the infrastructure itself, that data set, we are encrypting the data on upload to the GTS platform itself. So it's all being secured in that sort of environment, and the data transfer across that system as well. So I'm making sure it's in a secure cloud. There's also a concern regarding data sovereignty and tenancy. And we're making sure that within the different users who are uploading their data sets, that's all being separately siloed. So there's no crosstalk between different client systems and different client data sets to make sure that your data is your data, and there's no sort of cross communication or contamination of access, that sort of matter. So if restricted access to the system, restricted uploading and secure in that manner, and restricted storage and partitioning of that data set.
Great, thanks for that. And definitely cyber risk and resilience is definitely an important topic at the moment. I'll go to another delegate question that has come through. We have one from Sean Murdoch, who is the Technical Director at Industrial Digital. So Sean, firstly, he says great presentation, and he asks, how did these solutions resolve the issue of a single source of truth for master data? Sean says, this could be illustrated with talking through an example of a pump replacement, new serial number, etc. So I'll open this question up to our speakers as well.
Archie, you want to manage this one because I know you're going to talk about AF.
Well, indeed. So sorry, I'm the one who's answering all the questions here. So the way we manage this system in place is we will have a core asset component representing what's actually being measured, what we're measuring at this point here. But we can then bolt on the more metadata components in place. So what's actually the asset ID, any sort of updates, maintenance, or replacing components in the same sort of slot, that same location. That way we can make sure we are tracking the same profiles and relating things like a flow rate, which is not really tied to the pump itself, but more to the system. That's all in the same context, but we do have that clear demarcation between different changes in asset and how that's affecting these sort of trend profiles. So make sure there's a proper capturing between a change in the physical asset itself, but still maintain the continuity of the data flowing through the system and impacting the resulting components around that environment. We also make sure there's a time context associated with this. So when looking back historically, we do make sure we look at the right asset at the right time for that component.
Great, thanks for that. I think we have time for one more question. So this question is asking, what is the roadmap looking into the future? I might go to Gary for this one, if you have any comments.
Sure. You know, we've been working with GTS and they have these 5 applications to date, but as Steve and Andrew mentioned, we're absolutely open to enhancing that portfolio and having more applications and case studies. As you saw, one of my slides showed the number of applications that our customers are already leveraging. And the whole point of that is with the roadmap, and I'll defer to Andrew and Steve and maybe a bit more timing, but it's working with our water customers today and new ones, of course, to identify what is the most important for them. And again, making it very easily accessible and straight out of the box. That's really the goal.
Can I add something to, sorry to jump in there, can I add something to Gary's comments? We've displayed a few of the, demonstrated a few of the applications that we developed, but there were some others that we haven't shown today. Some of the things of interest to water corporations were implementing IoT devices, not just smart meters, although that was part of it, but other devices as well, solving that problem of integrating that data with the broader data sets from elsewhere within the business. And also to integrate other sources of data. There could be data loggers or devices that actually captured data in the field, and we needed to upload and integrate that data. So there were other things involved in the trial. But I guess fundamentally what we're advocating for here is that the community drives the future development. We are here to provide the tools and the expertise. Where do we go from here?
Yeah, just to add to that, energy efficiency is one of the ones which Gary highlighted as well. We are looking at and Andrea pointed on, we have looking at cathodic protection, which is an implementation that we've undertaken with Melbourne Water. How do we, subscribe to that component and delivery? Because we know it's a common issue with water utilities. energy management from a renewables perspective, we're seeing that, for example, water utilities are undertaking renewable implementations and solar farms and extracting energy from wind portfolios as well. So we are looking at a facility of how to integrate that for a zero energy cost component. And we've had discussions with various water utilities in that reference. And we've just undertaken a project to be the consultant for Riverina Water in how to manage and perform and integrate a solar farm into a water treatment plant down at Wagga Wagga. So.
Fantastic. Thanks everyone for all your comments and for answering those questions. I think in the interest of time, we might wrap up those questions there for today. But again, thank you to Gary, Steve, Archie and Andrew for sharing your expertise today. So that brings us to the conclusion of today's conference. Thank you to all of our delegates for joining us, and a huge thank you to OSIsoft, now part of Aviva, and GTS Group for bringing us this informative event. We look forward to seeing you at another virtual event soon.